Welcome to another VCE Physics coaching video. My name is Phil Noonan, and this week we're looking at the concept of frequency and time period. So this is nominally for Unit 1 Physics, which looks in particular at the wave nature of light, but this concept of frequency and time period applies to Year 12. In Unit 3 and 4, this concept comes up. So we're going to ask a couple of questions, and we've also got a bit of a tricky component to this question too, so just watch out for it when you come to it and see if we can all get it correct. So a wave is a transfer of energy without the net transfer of matter. Okay, so that applies to perhaps a mechanical wave for sound, for example, or it might be an electromagnetic wave for example, light, which gets looked at in Unit 1 Physics. So first, I'm just going to model an oscillating process here. Here's a little particle just going up and down. It's just representing variation, or it might be the level of electromagnetism. It might be the magnetic field strength or the electric field strength in empty space. It's just varying up and down. So time period is defined as the time for one cycle, starting from here. There's half a cycle, a full cycle, quarter cycle, half a cycle, three-quarter cycle, a full cycle, half a cycle, full cycle. Now, if that's just looking at something varying or oscillating, the word oscillate comes from the Greek word os for face, or bone is another word where it comes from. That's the word ossify, for example. And in vineyards in ancient Greece, there used to be little faces of the gods would be hung from the vines just to as good luck charms. And so they would swing in the breeze. And if anything was swinging, they'd say, oh, that's ossing, like an os. That's where the word oscillating came from. So I'll give this little oscillation a time base. That means I'm just moving it to the side rather than just up and down. I'm moving it to the side as well to give it a time base so we can analyze it more carefully. We don't say oscillating back and forth because the word oscillating covers it. We'll just say it's oscillating. So you can see here, I've actually drawn an example of a waveform which measures the time for, well, probably two complete cycles there actually. So 1, 2. And we know it's time period because the axis is time. And if that horizontal axis was labeled distance, then it would be wavelength, would be marked there. So time period, that might be a question we could be asked, is the time for one complete cycle. So I'll mark it with a special highlighter. That's the time period there. But this could also be the time period. All right, but to make it easy, we can, if we wanted to measure the time period, we would just measure this time here, as you can see. So if I made a bit of a question out of this, I'm going to ask two questions. A, what is the time period? Symbol T, it's equal to 4. It's that 4 there. But here's the twist I was telling you about. When measuring time period, just take particular note of any scaling factors on the axis. And sure enough, you can see a little m for milli there. So I'm going to put 4. Instead of writing m for milli, write 4, might make it 4.0 by 10 to the minus 3. And that'd be seconds. So S, or seconds, is, I should have written that up there. Seconds is the SI unit, the unit we normally use for time period. So then we introduce the concept of frequency. Frequency is a number of cycles that occur in 1 second, and it's defined as 1 divided by the time period. So that would have the symbol per second, but it's given a special name, Hertz, named after Heinrich Hertz. So if we wanted to calculate the frequency of this, a particular waveform or oscillation, we would just write F equals 1 over T equals 1 over 4.0 by 10 to the minus 3 seconds. And if you run that through your calculator, you'll get 250 hertz. That's the 3 figures there. If I wanted to make that 2 significant figures, I'd make it 2.5 by 10 to the minus, excuse me, by 10 to the 2. So I might put a box around that one. So that's a simple question. It might be asked at Unit 1 or indeed Unit 3 and 4. But we've defined time period as the time for one complete oscillation. That might vary from wave to wave. In light, for example, it's infinitely variable, can be any frequency, just depends on the what is producing the oscillation in the first place. And yeah, so the frequency is dependent on the oscillating medium, not on the medium itself that carries it. We can look at that a bit more another time. And so frequency equals 1 on T, or alternatively, if you're given the frequency, T equals 1 on F is the corresponding formula as well. So hope that serves you. If you have any comments or questions, just drop a comment in the description box. And in the meantime, thank you for watching another physics coaching video. And if you'd like any coaching or help preparing for your VCE examinations, either in Unit 1, 2 or Unit 3, 4, my contact details are in the description box.